finish the lesson Friday. Monday.
No, it's due Friday at midnight.
What?
Okay.
Therefore, you should just do it Thursday.
I'm recording, so I'm going to start the lesson, but I will think about the schedule. So an infinite sequence
Nicole thought she was getting out of the thing.
is a collection of real numbers that is 1 to 1 with the set of positive integers. And these sequences have a very specific order. Their order is noted by a term value A of n, where the n value tells you what number term it is in the sequence. So A of 1 is our first term. A of 2 would be our second term. A of 3 would be which term? The third term. And it just goes on and on and on. We also have a way of generalizing what our terms are and how we find them. And this is called our nth term. And this typically gives us whatever the rule is that the sequence follows. This is usually given to us, but sometimes we do have to find it. When they write the sequence, all of these are ordered. And we use a ... to indicate that it continues on infinitely in the positive direction. So this would be ordered as A1, A2, A3, all the way through AN and beyond. It can also be said that an infinite sequence is a function whose domain is the set of positive integers, because I have an infinite number of terms denoted by positive numbers. So this is term 1, 2, 3, 4, 5, and it just keeps going. So what we're going to do is we're going to practice identifying and finding the first few terms of a sequence given its nth term rule. And then we're going to kind of work in different directions. So the first example we are going to look at asks us to list the first 4 terms in the sequence. And then to also find the 10th term. Thank you, Molly.
Those are just defining patterns.
No, it already gives us the pattern. We are just using that pattern to identify the terms. We will eventually do finding the patterns though. So in this particular example, we really can't find the terms unless we know what the the sequence definition is. And that sequence definition is usually given to us in curly brackets. The sequence definition for this one is n over n plus 1. So anytime you see something in curly brackets, that indicates that it is the rule that this sequence follows for each of its term values. So we're going to use this rule to identify the first 4 terms of my sequence. We always start at A1 because that's the best place to start. So my first term, A1, would be this rule with 1 plugged in for n. So this is going to be equal to 1 over 1 plus 1, which simplifies into 1/2. So the first term in this sequence is 1/2. Then I find the second term. Any ideas about how I'm going to find the second term in the sequence? Plug in 2 for n. When I do that, I get 2 over 2 plus 1, which equals 2/3. Everybody okay with how I'm doing this so far? Go ahead and find the third and the fourth terms on your own. and then we will find the 10th term together. Bless you.
So we're finding the 10th one together.
Yes.
You just write it as like 810.
A10, yes. Yep. Did anybody have issues finding terms 3 and 4 for the sequence? Do we notice a pattern that's occurring here on all these terms? Yes. So that's what's really cool about this is once we do the first couple, we see how the sequence is progressing and how the terms are changing. That's awesome. That's called our rule, but that's not really something that we're going to identify right now, but it's good that you notice. I have another question for you. Do I need to know the first 4 terms in order to find the 10th term? No. How do I find the 10th term from here? I just plug in 10 for n and solve it. So my 10th term is going to be 10 over 11. Since we didn't have to use the terms that came before it, this rule is technically called our explicit rule for the sequence. Because it means I can plug in any term value n, and I'm going to get the sequence value for that placement. I could plug in 100 if I wanted to, and it's going to tell me what the 100th term is without having to know any of the terms around it. Any questions on that? So what I like to do when I'm asked to find the first couple terms in a sequence and then some random term is I like to write it out so it looks like an actual sequence as my final answer, which makes it really easy to look at. So my first term was 1/2. My second term was 2/3. Then I had 3/4. Then I had 4/5. Then we jumped into the middle, and my 10th term was 10 over 11. So that's how I like to write it when I'm given a question like this one. Makes it really easy to identify what sequence values are where. Everyone okay with that? This is how I would like your answers written for a question like this one. Major issues, questions, concerns with any of this? Is this a nice change from trigonometry?
Yeah.
Yes, I thought it would be. Okay. So what I'm going to do now is I'm going to give you another explicit rule, and you're going to find the first 4 terms and the 10th term on your own. So for this particular rule, we get 2 plus 0.1 to the nth power. Again, I would like the first 4 terms, and I would like the 10th term as well. You might want a calculator for this. I mean, you can do it without a calculator, but
We do 1, 2, 3.
1,
4,
2,
10.
3, 4, and 10. Yes. Thank you.
Is that the right numbers?
I want it written out like the previous one.
I did not keep space to be right. Wait, Mr. Reminder.
Give me a second, Colin.
This is like it, basically, or is there something?
There's more.
Is this it? How come when it, you like square root of 10 or whatever, square it goes down?
Yeah, it should. Calculate.
Because it still does zeros.
That should be wrong.
You're on. I'm just writing this down.
Yeah, it just, yeah, it should have 9 zeros in it. Some calculations you can have like alphabet. Not that when it should. Yeah, so you should definitely do the
0.1 to the 10th first and then add 2 and it should work out better that way. Okay. Ethan, what's my first term here? 2.1. Anybody else get 2.1 as the first term? Good. Jackie, what's my second term?
2.0.
I'm not going to ask Gabe next. Nicole, what's my third term?
2.0.
Are we noticing the pattern already?
Yes.
Yes, we're just adding a 0 in there each time we do it, which means that I can estimate that my fourth term is going to be 2.0001. Am I correct? Yes. Of course, you would prove it with your calculator. What then is my 10th term?
So you have 9 zeros.
It is 2.9 zeros and then a 1. Some of your calculators rounded.
Well, I have a really small decimal, so.
But it should be 2 and then 9 zeros because the number of zeros is 1 less than the term number that I'm trying to find, and then a 1 at the end. That should have been your 10th term here. If you put it into your calculator and it went from these numbers back down to a 2, you should know something is up because it shouldn't get smaller after it's grown bigger for so long.
I've been told to only go to
Wait, isn't it technically growing?
You getting sassy with me?
the point.
It is growing, yes.
I,
No, it's
I was
getting
just
smaller.
told.
Well, it's growing, but the growth rate is getting smaller. So it did a big jump from, no, it didn't, just kidding. Yes, it is getting smaller, but it's not getting smaller that fast. So make sure you are checking to make sure that your calculator didn't round on you because it has a nasty habit of doing that, especially if we have something like this happening. So once you note the pattern, you should definitely check to make sure the pattern held through. Any questions on this one? No, we're okay? We're gonna do one that's a little bit more complex, and then we're gonna move on to the next section. So this third one has the rule -1 to the n plus 1 power times n squared over 3n minus 1. So this is my rule for this third infinite sequence. Again, technically this is an explicit rule because I can plug in any term number n and it's going to give me the sequence value.
Is it gonna be like obvious to tell which ones?
Wait, you just want the explicit?
Well, it's always explicit if it's given to you like this.
You just want the term or you want?
No, I want 1 through 4 and I want the 10th. So if you feel comfortable working through it on your own, please do so. If not, I will walk you through the first 4 and then we can do 10 from there. So term 1 is going to be that explicit rule with n plugged in or 1 plugged in for n.
This is just a gross rule.
And we should get 1/2 as our first term, right? Is anybody following me or are you all doing it on your own?
You just work
just went faster through it, so.
Okay. So that was term 1. Do we all see how it worked out? If you had questions before. Ethan, you okay? Okay, so let's do term number 2. If you want to do it on your own, go for it. If not, I'll write it up here.
You definitely gonna write it faster than I am. So.
I'll write really slow. I'll do column level slow.
Wow. Okay. I don't think that was called for.
That's.
But you all got a
Nobody in here is dumb. Please don't say that.
Right.
Did anybody else get the same answer I'm getting? Okay. If you did, move on to the 3rd term. And then after you did the 3rd term, do the 4th term. And then the 10th term. And then you're done.
See, you can't really use the fraction. You want to do fraction.
I prefer, yes, it should be in fractions.
What if there's a mode in the calculator? Just
You can change it to fractions.
can you?
Yes.
How do you do that? Oh, there is.
I told you.
Crazy.
It's like I lied.
I know. I didn't get what you got though, so that's crazy. Bro, that's gonna be so.
Is anybody else getting the 5 terms that I have up here on the board? I did.
Extreme.
Yes.
See what I typed in wrong.
Which one would you do?
I did 2. Now I'm just writing what you wrote.
Oh, I know what you do. You have to put your denominator in parentheses.
Oh. There's a lot of text for parentheses.
I don't know what that was, but anybody not getting these numbers? I know I probably worked through it faster than you did, so it's fine if you're still working, but are we getting these numbers as our outcomes? Anybody super confused by how we got any of these numbers? I will say if you're plugging it directly into your calculator, you should put a parentheses around that denominator right there. That's the number 1 mistake I usually see happen.
Twice or
If we're all good, we are going to go ahead and move on to the next portion. And you can always come back and finish this one out. Okay. So what I want to do now is I actually want to take a rule and graph it. That's what I want to do next. It's really no different than what we've already done, except we're going to be putting points on a graph and drawing a graph at the end.
that's definitely different.
So what I would like to do is I would like to graph
I like solving apart.
the rule n over n plus 1. So the good news is we've already done the work to find the first 4 terms in the sequence and the 10th term. Right? We already did that. That was example A. So we already know the sequence values, which means all we really have to do is put the points on the graph. So let's write out what those sequence values are. I'm going to write it in a table because that makes it a lot easier for me. And I will suggest that you do the same thing for this. So the first thing I have is I have my term numbers. So those are our n values. And then I have what the term actually is, which are the a of n values. The n here are our domain. The a of n are our range. Okay, so these are our inputs, our x's, and these are outputs or our y's. You can also write that if you need to. And so I'm just going to go ahead and write out the ones that we already calculated for this sequence. My term number 1 for the sequence was what? 1/2. My term number 2 was what?
2/3.
Term number 3. Term number 4.
4/5.
And then we jumped all the way down to term number 10. And that was what? These 5 points are enough for me to graph this. You need at least 5, I would say, to graph an infinite sequence like this, just to make sure we get the most approximate shape of the graph. So we're gonna go ahead and we're gonna draw our coordinate plane. None of these are negative values, so I can look primarily in quadrant 1, because everything here was positive. On my x-axis, I'm gonna go from 1 to 10.
Probably because we stopped doing slope and did weird stuff.
And then what was the biggest y value I got from this table so far? Nope.
1.
10 11ths. So what I noticed is that these values are getting increasingly closer to what number?
1.
1. So that needs to be the largest y value I put on my graph. Of course, you can split this up into halves and quarters if it makes it easier for you to approximate where these numbers go, or these points go. And then we just start plotting them. So 1/1/2 is my first point. So I'm going to go to x equals 1, and I'm going to go to y equals 1/2, and I'm going to put a dot. I'm going to do the same thing for 2 2/3. I go to x equals 2. I go approximately to where 2/3 is at. Then I go to 3 3/4, and I just keep plotting these to the best of my abilities. I understand that it won't be perfect because we are freehanding this. Once I get the first 4, I'm going to jump down to 10. Again, we are just plotting this to the best of our abilities. Once we have our 5 points on the graph, we can draw the curve that goes through them. We must put an arrow indicating that it goes infinitely in the positive direction, because I know all infinite sequences do. I have another question for you. Is this graph ever actually going to reach 1?
No.
No. So technically, we have what kind of asymptote at 1? A horizontal. So you can actually go ahead and draw that in if you choose to. Just showing that though we're growing infinitely in the positive direction, we never actually reach 1. We're just going to get infinitely close to it, the more terms that I have. Does that kind of make sense? Anybody super confused by that? No, we're all okay? I'm going to ask for a 1 to 5 so far, just to see how you guys are really feeling about this. 1, absolutely no idea what's happening. 5, you could show somebody else how to do it. So 1 to 5, how do we feel so far? Oh, I'm seeing lots of good numbers. Okay, so let's go ahead and look at the next portion. In this one, we're going to still find the first 4 terms, but we're going to do it from a different rule. Oh, hold on. I'm going to write something first. I apologize. So when we were finding the first four terms on these examples, we were doing it, yes ma'am, I moved it over.
Okay,
Yeah. We were doing it from an explicit definition. So I could plug in any n value and the output would be that term number from my sequence, right? So if I plugged in 100, I would get the 100th term value. If I plugged in 50, I would get the 50th term value. Not all rules are given that way. Some of them are actually recursive rules, which means it tells me how my next term grows from the term or terms that come before it. So for example, if I looked at, I don't know, let's say 1, 2, 4, 8, 16, and so on. What's changing from term to term here? It's multiplying by 2 or it's doubling the term before it. So that actually doesn't help me if I want to find the 100th term, because I'd have to know the 99th term in order to find the 100th term, right? And to find the 99th term, I'd have to know the 98th term because I'd have to double it to get to that one. So this rule that we just eyeballed tells us how it builds off the term before it, but it doesn't tell us how to find any random term in the sequence. So this doubling, or 2 times the term before, would be what we consider a recursive rule. So what we're going to do now is we're going to find the first 4 terms in a sequence, or the next 4 terms in a sequence, given a recursive rule that shows how it builds from the term or terms that come before. So this example asks us to find the first 4 terms and the nth term given a recursive definition. If it ever asks us to find so many terms from a sequence, it either has to give us the recursive definition or the explicit definition. One of them has to be given to us, otherwise technically we're just guessing. We love guessing, but it's not how we do this. So we have to know one of those rules in order to find sequences or terms from our sequence. On this particular example, I have the given information. I know that my first term is equal to 3, and I know any term that comes after that one is equal to 2 times the term before it. That's what AK means. So to find AK plus 1, which is the next term, I do 2 times the term that comes before. This could also be written in another way. It could be AK equals 2 times A of K minus 1. They mean the exact same thing, just different notation. It still means to find this term, I have to do 2 times the term that came before it. These are 2 different ways of writing a recursive definition. So if I want K plus 1, I have to know what K is. If I want to find K, I have to know what K minus 1 was. I have to know the one that came before it. So K comes before K plus 1, and K minus 1 comes before K. It's new. I do expect that you're going to have some issues with this, okay? It's okay if you do. It has to give you the definition, yes.
So it gives you that.
It has to give you either this or this.
So then you'll plug in 3 for
Okay, yes. So what we're going to do now is we're going to use the first term, and we're going to use the recursive definition, and we're going to build the first 4 terms from that. The cool news is I already technically know the first term, right? A of 1, it told me is equal to 3, so that's term number 1. How then do I find term number 2? Well, I go to A of 2, and it tells me that that is 2 times the term that came before it. So that means it's 2 times 3, which is 6. That was plus 1. So 2 is 1 plus 1. This just means the next term, and this means the term before it. So if my first term was A1, 1 plus 1 is 2. So this means this is A2.
Here's double.
Because 2 is 1 plus 1. So it means it's the next one after 1.
Okay, so
It's very confusing, and I know that. I do. Let's get through the example, and then maybe we can rephrase it in a different way. So I have the first term and I have the second term. How do I find the third term?
just double the 6.
I go back to the term that came before it, and I multiply it by 2. So that means A of 3 is equal to 2 times the 2 times 3 that created my previous term, which makes it 12. Because it asks us to find the nth term as well. So while we're doing this, we're also building an explicit rule.
I was confused because I thought plus one was actually part of the equation.
No, the plus 1 is not part of the equation. It just means the next term. Because this just means the previous term. So both of these mean the term that came before. Both of these mean the term that comes next. They're just different ways of looking at it. Okay, so that was term 3. How do I find term 4 then? Well, how do I find term number 4?
Okay, you're
2 times 6, or 2 times what I multiplied together in the previous step to get my answer.
maybe not though. That seems like a little bit extra. Wait, can you
It
spell-
asked me to find the first 4 terms, which I did, but it also asked me to find my nth term, which means that I need an explicit rule here. How did writing it like this help me see a pattern that was happening? I just increase my 2 every time. So my first term was just 3, which is the same as 2 of 0 plus 3, right? Or not plus 3, times 3. This one was 2 times 3. So this is the same as 2 to the 1 times 3. A3 was equal to 2 squared times 3, because I had 2 2's there. A4, how many 2's did I have?
3.
3. Are we noticing a pattern between the number of 2's and the term value I'm trying to find? Yes, what is it?
1 less.
It's 1 less than the term number I'm trying to find. So if I'm trying to find the nth term here, I'm going to take 2 to the n minus 1 power, and I'm going to multiply the answer by 3. And that's going to give me my nth term. Yes?
So 2 times 3, so then you put that where the AK is,
Yes.
and then every time.
Every time. I just took what was in the step before and put it where AK was.
So you'll do that for every one.
If it asks you for a recursive, yes. Yes. Does this make sense how we built AN from this? If it asks for AN, you should definitely write it out like this so you see the pattern emerging. If it just asks for the first 4 terms, you don't have to do that. You can do just like 2 times 6 and 2 times 12 and so on. Just whatever works for you. But if they say they want the nth term, you should definitely write everything out so we identify the pattern. Questions, concerns, or issues with that? Oh, sorry, honey. Okay. So what we're going to do next is we're going to do another example, and then we're going to stop. Because this will put us halfway. Okay?
Of the same thing.
Kind of different.
Like
Kind of different, but same idea. It's building off a recursive rule.
Are
So
we
this example,
Are we gonna have to find explicit rules every time?
not every time, no. This example asks us to find the next 3 terms of the infinite sequence. Defined recursively below. So this tells me that A of 1 is equal to 4, A of 2 is equal to 7, and A of k plus 2 is equal to 3 times A of k minus 1 minus 2 times A of k.
He wants us to find the first 3, but gave us the first 2.
It says find the next 3.
Oh, next.
Yes. So this one is a little bit different because it doesn't just feed off the term before, it feeds off the previous 2 terms before. But it still works the same way. Okay.
But how did they find the first term?
They had to give it to you. Like they have to tell you where the sequence starts.
Yeah.
What did you say, honey?
Let's go back to.
Oh wow, trig over this.
Honestly, like,
No, just the start of this one. Just the start.
Okay. So let's start with what we know. We know that A of 1 is equal to 4. And we know that A of 2 is equal to 7, correct? They told us that. What it wants is the next 3 terms, so I need term 3, 4, and 5. So let's start with term 3 because it's the next one in sequence. This says that term 3 is equal to 3 times term k minus 1. Here my k, oh my gosh. Yeah, k minus 1 means, I think I messed that up. Should I write it right? Oh, it's k plus 1. That makes so much more sense. So this means the term before, which would be A2, minus 2 times A of k, which is 2 terms back. Yes.
No.
Yes.
If A of K is the term before, how is A of K plus 1 the 2?
No, A of k plus 2 is what we're trying to find. So plus 2 would be 3,
I thought it-
plus 1 would be the term before, and A of k would be 2 terms back. The alternative way of writing this would be A of k equals 3 times A of k minus 1 minus 2 times A of k minus 2. If that helps you anymore.
But A of K doesn't mean
In
the
order
term
to get
before.
A of 3, K has to be 1.
Yes, in order to be 3, k has to be 1 because 1 plus 2 equals 3. So that has to be A of 1.
So K doesn't mean the term before, it just means the.
No, k can be any term that came before it. It doesn't have to be the one directly in front of it. Yes, this is hard. I know it's hard.
It's just a bunch of letters and numbers. I don't see anything holding together.
Do we see how we got A of 3 from that? So this one might be the best one to look at. If I'm looking, stop talking. If I'm looking for A of 3, I do 3 times A of k minus 1. So if k was 3, 3 minus 1 is 2. Minus 2 times A of k minus 2. My k here is 3. 3 minus 2 is 1. So then all I do is I filled in, or I will fill in, A of 1 and A of 2 for what they are. And then I will simplify it out. And you should get 13 for this one. So that means A of 3, or my third term, is 13. I know this is hard, and if you struggle, that's fine, but we need to keep trying it. So that was A of 3. Now let's try A of 4. So A of 4, 4 here then is my k if we're using this bottom one, because I like this one better. Then k minus 1 is going to be my third term, and k minus 2 is going to be my second term. We just keep moving back 1 when it says subtracting. So this equals 3 times k minus 1, which means the term before it, which was A3, minus 2 times k minus 2, which means 2 terms before it, which was A2. And then we just plug in those term values. So this becomes 3 times 13 minus 2 times 7. I believe that comes out to what, 25?
Mhm.
Are we starting to see how this fits together? I know it's hard, so please don't, if you're struggling, that's fine. I'm not undermining that or saying you shouldn't be, because it is difficult, but we just need to keep trying it. Okay, so we just try to approach it from a different way that might make more sense. That's all I'm going for here. Is this making any sense at all, Marissa?
No.
No, okay, so you and I are gonna work on this. Let's go ahead and do A5 so we can finish up this example.
Wait, we don't have to do it as a term for.
No, because it just wanted the next 3
Okay.
on this one. It did not want an explicit, and thank goodness. So A of 5 here, 5 is K. So K minus 1 would be A4. And then K minus 2 would be A3, because 5 minus 2 is 3 and 5 minus 1 is 4. There's a pattern here. So I start filling in the values. A of 4 was 25. Oh, it's a 3, not a 2. A of 3 was 13. And then I just do the math. What's that one gonna be? 49. I can't do basic things.
I was wondering how you were getting 36.
Yeah, no, in my head, this was 3 times 13.
Yeah, that's what I did too.
Okay, so it would have made sense if it was 3, but it was 2, so. And then that would be it, because it just wanted the next 3 terms, which we found. So we found A3, A4, and A5.
How do you go about finding the easier, the different, like this said the AK equals 3 times?
I will always give it to you like this. This is just the way they like to give it to you. So what I do is I reverse. So I always treat AK as the one I'm working with. And then I just figure out what is the difference between this term and this one. Well, this is 1 less than this one, so I did K minus 1. And this one is 2 less than this one, so I did K minus 2. I will always give it to you this way because I think this is the better way of looking at it. If any of you like this way, I guess I can put that too, if that's what you want. Does anybody like the top way versus the bottom way? I can put both if that's what you want, but I like this way better. I always like to think of A of K as my current term, but that's just me. And as I already mentioned, if it doesn't give us a recursive rule or an explicit rule, we cannot solve the sequence because we are just guessing at that point. We have no definitive proof or solution process to find any future sequence terms. Okay, this is where we're gonna stop for today's notes.
How would you find the explicit rule for this? I know it doesn't ask for it.